Starting with this lecture, we are going to discuss classic synchronization problems. The first such problem is the bounded buffer producer-consumer problem. Just a reminder, what we are trying to do here is to discuss how we can use basic building blocks, synchronization primitives in this case, to compose applications that have certain semantics. So for the bounded producer-consumer buffer, it looks like this. We have one producer that wants to add items in a queue and a consumer that reads them. As you can imagine, the queue itself is what we need to handle with care inside the critical section. Why is that? Because the producer must be sure there's space in the buffer before adding an element. It is a bounded buffer. And the consumer must be sure there's something in the buffer before reading it. Let's try to find the solution for this critical section using semaphores. A way to put down such ideas is to draw a diagram like the following one. As you can see, each critical section of a thread is wrapped in a lock. This is what we just discussed before. The unlocking of the critical section of a thread precedes the locking of the critical section of any of the two threads. For the producer, an extra wait should precede the locking of its critical section, because if the queue is full, the thread has to wait. For the consumer thread, a while loop should precede the locking of its critical section to make sure there are actually elements in the queue. When can the producer exit the while? After the consumer removed an element. This can be signaled for sure after the consumer exits its critical section. When can the consumer exit the while? After the producer added an element. This can be signaled for sure after the producer exits its critical section. If you draw such a scheme, it's then easier to come up with pseudocode like the following one. As for the previous lecture, take a moment later on and think about how to formally reason about the validity of this solution.